Okay, so when we're talking about the properties of alcohols and ethers, we also need to talk about their solubility. So, how well they dissolve in things is what solubility talks about. We're specifically going to be talking about their solubility in water. So, in water, the main thing that determines solubility is how many hydrogen bonds can be made with water. So, water loves to make hydrogen bonds. So hydrogen bonds are the attraction between a partially positive hydrogen atom and a strongly electronegative atom like fluorine, oxygen, or nitrogen, which is partially negative. It's very similar to our ionic bonds, positive, negative. It's just kind of on a smaller scale. It's not quite as strong because it's not full-blown charges. It's kind of partial charges. So like when you look at an alcohol, like this molecule here, ethanol, we're going to have a slightly positive hydrogen atom and a slightly negative oxygen atom. Those can interact with the molecules in water. So the partially positive part of hydrogen is going to hydrogen bond with the partially negative part of water. We draw this as a dotted line since it's not a covalent bond, it's not a full bond, but it is a good interaction between the two. And then additionally, let's switch colors. We have the negative part of the oxygen is going to interact with the positive part. That's really dark. Let's try a different one. The negative part of the oxygen is going to interact with the positive part of water so that you have these interactions here. So there's two lone pairs. So each lone pair gets one interaction with a hydrogen. So alcohols can form 3 hydrogen bonds with water, 2 from its lone pairs, 1 from each lone pair, and then 1 from the hydrogen. So thinking about that, how many can ethers form? How many hydrogen bonds can ethers form? So take a moment, pause the video. But let's draw an ether real quick. So if I look at an ether, I'm going to draw in these lone pairs. I have 2 lone pairs. Each of those lone pairs can hydrogen bond with the H part, the positive part of water. Oh, that's not an H. Okay, so we looked at that. We have that negative part of ether. What about the positive part? Well, in this case, we don't have any positive parts because we don't have a hydrogen off of an electronegative atom. We do have the hydrogens on like the carbons that I drew, but those are pretty much nonpolar. They don't really have a charge. So ethers can form 2 hydrogen bonds, interactions with water. So because of this, the more hydrogen bonds that a molecule has with water, the more likely it's going to interact with it, the more water can get around it, and the more soluble it is. So alcohols are more soluble than ethers are. So this is soluble, and this is slightly soluble. So they're more soluble in water than ethers are because there's 3 H bonding interactions, whereas there's only 2 in ethers. 3 H bonds in interactions in alcohols. I did not say that. Okay, so let's look at these some general rules for this. So for alcohols, you'll notice, let's maybe highlight. We have these first 3 are alcohols, and then the last 2 are ethers. So that's why there's kind of 2 different groups here. When we have a small number of carbons, the molecules are soluble. So the number of carbons also determines the solubility. So the carbon part of the molecule is not soluble. There's no interactions at all. So if you have a lot, like a lot of parts that don't interact with water at all, and one part that doesn't necessarily, that typically means that it's not soluble. that it won't dissolve because the parts that are insoluble are stronger than the parts that are soluble. So when we have a small number of carbons, a small part of the molecule is insoluble, but we still have that alcohol there. In this first line, those are going to be the molecules that are soluble. When we have kind of in the middle, so for alcohols, it's 4 carbons. When you have 4 carbons, it's going to be only slightly soluble. So not as much of the molecule can dissolve in the water. And then lastly, we have if we have a lot of carbons, so more than 5 carbons, we're going to have insoluble alcohol. Continuing on, we have our ethers. And so when we look at ethers, we have more carbons overall, and we have less possibility for hydrogen bonding. There's only 2 interactions. So if we have 1 to 4 carbons, we only get to the slightly soluble part. And then if it has more than 4 carbons, it's completely insoluble. So you guys should reference this chart for the functional groups for ether and alcohols to know if they're soluble or not, or to guess if they're soluble or not. So looking at this chart, let's look at these molecules and see if we can predict if they're soluble or insoluble. So the first one, we have a really long chain of carbons, and then an alcohol in the end. I'm not even going to count how many there are because I know that there's at least more than 5, and that means that this molecule is insoluble. Okay, so in the second molecule, we have an ether that has 1, 2, 3 carbons attached. So if we have an ether with 3 carbons attached, I'm going to erase those are pretty bad. 3 carbons attached, that means according to our chart, this is going to be slightly soluble. And our last one, so we have a alcohol that is 3 carbons. 1, 2, 3 carbons. So an alcohol with 3 carbons, according to our chart, is soluble. So that's how you read it. You look at the functional group and you look at the number of carbons and see if it would be soluble or not. Okay, so that is all about our solubility of alcohols and ethers, and I will see you guys in the next video.